Okay, so we had 4 different types of confidence intervals. The first one we looked at was about the population mean, mu. Okay. And with that confidence interval, we had to find our point estimate. What was the best point estimate for the population mean? What did we use for our confidence intervals? We added and subtracted our margin of error from it. You may remember. It's been a couple weeks. So this was our X bar. Okay. So our summation of X divided by N, or if you're plugging everything into your calculator, that very first thing that gives it to you in the list. Okay. Okay, so then we have our critical value. And we have 2 different types of critical values. What are the 2 types? Table 4 and table 5. Z and T. How do we know the difference between the 2? When do we use a normal distribution? When we're talking about the population standard deviation. Okay, so when that's given to you, and that's going to come from table 4, primarily in that little box on the bottom of that front page. And then T distribution, that's when sigma is unknown. And we use table 5. But what is special with table 5? What do we have to also find based off the sample size? Degrees of freedom. N minus 1. Okay. And then we find our margin of error. Okay, so when we're using ZC, our margin of error E is simply our critical value times the standard deviation divided by the square root of N. Okay. And we're using TC, it just changes. TC, critical value, times S divided by the square root of N. Okay. And then you just add and subtract. Okay. Then we looked at confidence intervals for the population parameter P. And what was our point estimate here? Anybody remember? It was P something. P hat. So X divided by N. What critical values do we use here? Do we use normal or T? Anybody remember? Normal. So from table 4. Okay. And our margin of error formula E equals the critical value times the square root of P hat, Q hat divided by N. How do we find Q hat? 1 minus. Okay. And then the one we talked about last week, or Thursday, Friday, was chi-squared. Oops, how about that? Not that. That was our distribution. So either the standard population standard deviation or the population variance. Okay. Our point estimate for these, we didn't really talk about specific, but that's going to be S and S squared. We get the sample standard deviation and the sample variance. And then this was our new critical values. What was this one called? Chi. So chi squared, right? And chi squared left. So here we're using table 6. we have to use that idea of degrees of freedom equals n minus 1. And then remember, define chi-squared right's alpha 1 minus c divided by 2. And then when we find chi-squared left's alpha, what was the shortcut I told you guys? 1 minus. Whatever you get when you find the chi-squared right. Okay. And then our formula changed a little bit here for our confidence interval. Instead of adding and subtracting our e, this is probably the hardest formula, so let's go ahead and rewrite that one. That's where we're going to do n minus 1 times the sample variance divided by chi-squared right is less than, oops, we got the right direction. The population variance, which is less than n minus 1 times s squared divided by chi-squared left. And then how do you change that from variance to standard deviation? Square root it. Okay. So that's kind of summarizing everything we've done. Okay. So make sure you're reading it. If it tells you something about finding the confidence interval for a standard deviation or variance or using chi-squared, okay, if it talks about percentages or x and n, you know you're using population parameter. If it talks about the population mean, that's when you're using what we started with, okay? So let me stop recording.